Here we go, graphing review for our semester final with your host, Newbold, and Tigger 2. Hoo! That was terrible. I'll try again later. All right, here we go. Okay, let's see. So, given the function below, graph f of x minus 2 on the same coordinate plane. So all that's saying is to go ahead and shift your graph either to the left 2 or the right 2. If it was outside, like this, for example, it would shift your whole graph up 2. But because it's inside the parentheses, it's going to be opposite what you think. So it's going to be right 2. So opposite when it's inside the parentheses. Don't forget that. Parentheses. Cool. So we're going to go ahead and take our graph here. And so we're going to go ahead and take this point 2 and move it over to 3. Let's use a different color. So we'll go ahead and use red. Ooh, let's do a dashed line. What? So then we're going to take this one and move it over to here. And this line over to here. So that means it's going to come down just like this. In the same way, same fashion, and go up like that. And then, let's see here. So we just shifted all over to the right. Oh, we have to shift to the right 2. What? Shift to the right 2, not 1. Okay, so that means if we're going to shift it to the right 2, that means this would be over here. So that 2 would go over to there, 2, right 2. Awesome. And so then the next one would be here, the next one would be here, the next one would be here. Because right there, 4 in a row. Cool. So then this goes up, this comes down and makes our Weber High Warrior W up to 4, and then down again, and then go up again. That's it. So we can see, let's double check it, that kind of shift there. So we were here, and then, ooh, that's an awful drawing, Newbold, sorry. And then we did shift right 2. Yeah, because this guy went over there. Perfect. Okay, so that's what it means, shift to the right 2. Okay, so now we're going to jump over next to absolute value. Remember, that's the flying V for absolute value. And so again, this is going to be inside, so it's opposite what you think. So I know you think left 5, but it's actually right 5, and then up 2. Up 2. Okay, so we start off at 0, 0, the parent function. And we're going to go right 5, so 1, 2, 3, 4, 5. And the reason why is if you plug in a 5, 5 minus 5 is 0, right? If this is y equals, and so let's say you did an xy chart, and so let's say that you chose x to be 5 and you plugged it in, and then when you plugged it in, you got 5 minus 5 is 0. So that's our vertex, 5, 0. Hopefully that makes a little bit more sense why we do the opposite inside. And then up 2, on 2. So that's called the vertex, right? Remember that, vertex? And so all the absolute value, they go up and to the right, and then up and to the left. That's the flying V for absolute value. Now you can use your graphing calculator on the test, so that's awesome. And so, but you have to know where to find ABS, absolute value. So we go to y equals, we clear our graph there. So it's under the math button, over to numbers for ABS. And so ABS stands for absolute value. Again, we went to y equals, then we went to math, absolute value, math numbers, absolute value. So then we want to go and type in x minus 5, right arrow, and then plus 2. Awesome. So then we go and push graph. And there it is right there. We're going to push zoom 6 to get a 10 by 10 graph. And so there it is. So you can see at 0, 7, which is where our graph is going to hit. The y-intercept, it carries on. And so excellent. And so that is correct. We did that right. And then our vertex down there at over 5 up 2. Over 5 up 2. Yep. Cool. Okay, moving on. So end behavior, cool. So this is a cube root. And so cube root end behavior goes like as you go to the right to positive infinity, y goes to the right, positive infinity. And then as you go to the left, negative infinity, y goes to negative infinity. Oops, y goes to negative infinity, that's it. Because a cube root looks like this. And so as x goes to the right, y goes to positive infinity. As we go to the left, it goes to negative infinity. Cool. So then it's 3 dots in a row is the cube root function. So we start off there, there, and there. And then the -4 means to go down 4. So we're going to go 1, 2, 3, 4. And then that means that we also go from here. 1, 2, 3, 4. And it's basically diagonal like that. Cool. And so then the cube root is going to go along, hit those 3 dots, and then carry on to the right, like Superman. Do, 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 do. So there is our cube root of x minus 4. Again, just use your graphing calculator if you're not sure. So x to the 3rd power, and then minus 4. Bam. And Newbold, you just did the cube root. You're supposed to be doing power of 3. Stupid! Oh. Good thing we checked on our calculator. Sorry. So what that's going to do is, so cube root is opposite of cube. So we are actually doing cube. So this is a cubic function and not a cube root function. So we're going to go to erase, erase, erase. There we go. And so a cube root function, so think about cube root, what cube root is. So cube root is an XY table. So cube root is basically kind of same thing but rotated. So if we choose some test points, -1, 0, and 1. And so then we plug those in. So that's the original, right? You plug in a -1 and you get a -1. This is for x cubed. And so y equals, plug in a 0, you get 0. Plug in a 1, you get 1. Cool. So the cube root function is more like this guy. Wait. Yep, like that. So it's kind of similar. But instead, it's actually exponentially growing and taking off. So what if we put a 2 in, for example? So, oh, I did draw it there. Did you see that? I did draw it there. New ball. So it's late. It's after school. Sorry. So 2 to the 3rd power would be 2 times 2 times 2 is 8. So we go over 2 and up to 8. Yeah, so this thing's just going to take off like that. And then also do the same direction like that. But that's the parent function. Now it's saying that we have to go up 4. So we're going to shift that sucker up 4. So we're going to go ahead and we're going to go, let's combine it first. Combine it. So we're going to go ahead and shift up 4. Do it with me. Ready? So we're going to go 1, 2, 3, 4. So there is our cube root function. Let's move our end behavior there. So there's our cube root function. 4. What the? So go to y equals. Newbold, you are not on your A game today. It says negative. So what does negative mean? Oh my goodness. Almost tempted to start this over. That's okay. Everybody makes mistakes. Everybody has those days. So down 4, Newbold. So back to the parent function. 1. Dang it. 1, 2, 3, 4. And word. Okay, so there it matches. So there's our graph. Excellent. There's our graph. See if it matches. It does match. So down is what's going on there. Cool. Okay, so there's x to the 4th power with opposites, so it's going to be a right 2. There, someone choose a different color now. Name drop, Kennedy's favorite, green. Again, is go ahead and go to y equals, and instead of doing the power 3 cubic, we're going to go ahead and do cube root. So that's math button, and here's the root, and here's the cube root. So of x to right arrow. Nice. So there. Let's do another video.